So the team have conducted a traffic impact analysis to ensure that the project have a minimal negative impact on the traffic system of the Damour city. Moreover, the team have conducted an environmental impact analysis to assess the environmental hazards that this project might cause and minimize them as much as possible. And of course, the geotechnical investigations, which are a must, and which also involve taking 4 samples of soil per villa to more understand the behavior of the soil per each villa. In addition to the land surveys, which were conducted by the team, which included the mapping, measuring land areas, and detecting existing structures, and more better understanding of the topography of the whole construction site.
Okay, so moving to the contractors organization on the field, of course they have a planning and control unit which was responsible for actually monitoring the progress and altering and modifying the schedules to be on time and actually have minimal delays. Of course, there's an engineering unit, including site engineers, which are always with the workers on site, making sure that the execution is actually in compliance with the design standards and the quality standards as well. There's a procurement unit in which they actually are responsible for bringing the materials and checking the availability in the market, as well as there's the quality assurance and quality control unit, which were responsible actually to make sure that the construction progress and the construction work is actually in compliance with the quality standards. It's kind of similar as the job of the site engineers, but actually it's for the sake of not repeating the work and avoiding delays, avoiding losing money and this stuff. Of course, they don't have a storage and warehousing unit because mainly the general contractor here provides the storage and the warehousing for the subcontractors. There is no need for labor recruitment. That's mainly because all the subcontractors have their own labor, own workers, and don't need to have a recruitment unit. They don't have a contract manager or a construction manager, and that's mainly because the contract manager issues and the management of the contract was dealt by the engineering unit. So they were the guys responsible for that topic.
Throughout our site visits and by contacting the people in charge on the site, we were able to detect the safety hazards as well as the implemented remedies on the site, and we added our own assessment for these implemented remedies. So as for the overhead hazard, the implemented remedy was to provide engineers with hard helmets. We believe that this remedy is very risky for construction workers as they are the dominant and majority in this site. As for the falling hazard, the implemented remedy was the fall arresting mechanisms, such as providing harness on scaffolds. And our own assessment is that it is preventative because it decreases the probability, but it does not decrease the impact. As for the projecting nails and projecting nails on wood planks and the nails on the ground, there was no implemented remedies, which we believe is insufficient and very risky. And our proposed solutions for these 2 hazards is to hammer the nails so that they are not projecting anymore, or by providing workers with safety boots. As for the welding and cutting hazard, the implemented remedy was to provide workers with protective goggles, which we believe is more than sufficient in implementing for site work.
The site layout is a dynamic deliverable, so it's changing with time throughout the progress of the project. So, and we decided to compare between 2 phases. So starting with the excavation phase. So the site layout at the excavation phase, as we imagined it to be, is somehow look like this. So we have the excavation. The excavation pit is right here, and we imagine that the excavators are freely to maneuver around it and do the excavation process. And then the excavated soil is actually logically should be nearby the excavation pit, so that the excavated soil is placed here, so that the dump trucks here can actually get the excavated soil and move it outwards. So this is the access of the site, and this is the ego of the site, which is the exit actually. So the dump trucks can easily get the excavated soil and get it out of the site boundaries, I would say. And here, of course, there's a water and power supply, as we imagined, because the excavation process will require a lot of power and will require actually water to facilitate the excavation process. So as you mentioned, this site layout is going to evolve with time. So now in the construction site layout is going to be, instead of having a excavated solid base here, we're going to have a steel depot, we have a stone depot and wood depot, as well as a crane, which is going to have a radius going around here. Instead of having an axis and eager here, we're just going to have an axis all over the place, moving from here to here. So it allows the better access because it's a construction site and it's better to have a free access. Of course, we added a carpenting and welding unit here because it's required for the construction work. The offices remains the same and the water and power actually remains. We observed that there is high level of productivity in the labor force, and that's mainly due to the high level of communication between the engineers and the workers on site, as well as due to the previous experience of the general contractor, because they are used to work on luxurious projects, and due to the effect of learning, which was significant. And that's mainly because the workers are working on repetitive and similar villas, so this added a lot to the productivity. As for the S-curve, which plotted the value of work with respect to the time, it shows actually the planned value, which is represented in the red, against the actual value, which actually shows a delay of 4 months starting at year 1. And that's mainly due to some of the logistic issues, which is related to the material delivery delay, the lockdown delays, and actually there was no permit delays. It was safe from that side. And the material delays were mainly due to COVID-19, and the lockdown delays prevented them from working. But actually they compensated for the lost time by doing extra shifts, and it's actually represented and reflected in the sharp slope increase in this curve. And that's mainly it.
As for the cost estimates, all the details are present on the slide, but we'll not pass over everything as this will take forever, so we'll just discuss the important factors. So for the land price, each meter squared costs around $700. The land area, which includes the garden around the villa itself, and the parking spots. As for the post-tension work, each meter squared costs around $10. As for the materials, the three main components were concrete, steel, and formwork. The 35 MPa mix of concrete costs around $80 per meter cube. The 30 MPa mix costs around $75 per meter cube, and all these assumptions are based on this number. As for the steel, the price per ton is $1,200, and all these assumptions are also based on this number. This is for the formwork, and the finishing work and the workmanship costs around $20,000 per each. So this adds up for the total cost, which is the $348,000, and the price of the villa, which is $390,000. So doing the math, each villa generated approximately $41,000, which is around 11-12% of ROI.